In this video, we're going to go through the code for being able to create a linked list. So we'll be able to create something that looks like this, and we're going to write a method for adding an item to the end of the linked list like that, and then we'll write another method for being able to remove the last item. But before we get into the code for writing the linked list class itself, we're going to write the code for creating a node. So the structure of a node is very similar to the structure of a hash map. So I like to visualize it like this before I write the code for creating a node. So we'll have two variables, value, which is an integer, and next, which is a pointer that can point to a node. So the node class will have class variables of value and next. And value is an integer, and next is of type node. So it's important to understand that that next variable is not actually a node. When you set a variable to be of type node, it means it can point to a node. So now that we have those class variables, we can build our constructor. So the constructor will have the same name as the class. The constructor will be called node. We will pass this a value, and then we'll say this.value equals value. So if you've never seen the this keyword before, this could be confusing. So the value that you pass this method is this value down here, but this.value is something else. So when we say that this.value equals value, this.value is this value up here. So this is how we're setting the value for this node. So now that we've built our node class, we can go back and start building out our linked list class. So linked list is going to have three class variables. The first one is going to be head, and that's going to be a pointer to a node. And then tail will also be a pointer to a node. And then we're also going to keep track of the length. So now that we have our class variables, we can start building out the linked list constructor. And what I'm going to do here is I'm going to just focus in on the constructor like this. So what we're going to do with this linked list implementation is we're going to create the first node in the linked list at the time that we create the linked list. And we'll create that node with this line of code here. So we take that value that we passed the linked list constructor and we pass it down here to the node constructor, and that creates a node. So I want to spend a little time talking about this line of code because if you haven't seen this before, this can be confusing. It looks very much like we're doing the same thing on each side of the equal sign, but we're actually not doing the same thing. So on this side, when we say node, newNode is a variable name, and that variable is a pointer that can point to a node. On this side, when we say newNode and we pass it a value, this new keyword means we're running the constructor for the node class. So this line here is what actually creates this node. And this equal sign in the middle is what actually takes that newNode variable and points it at the new node that was created. Then we're going to say head equals newNode. So I'm going to bring back the rest of our code here. And you can see head is a variable of type node, which means it is a pointer to a node. And newNode is of type node, which means it's a pointer to a node. So when you say head equals newNode, you're just making head point to the same node that that newNode variable is pointing at. So I'm going to bring this back up, and head equals newNode is doing this. So I'm going to take the newNode variable out of the graphic like this, and then moving forward, I'll just do something like this. Tail equals newNode, and then we understand that's the new node, and we are pointing tail to it. And because we're starting out with one node in the linked list, we'll say length equals 1. So let's bring back the rest of our code. This is our entire linked list class. We have our 3 class variables, and then we have our constructor here. So let's focus back in on this constructor again. The way we would create a new linked list would look something like this. Our variable name is myLinkedList. It is of type linked list, which means that variable can point to a linked list. And then on this side of the equal sign, we're actually creating a new linked list with that new keyword, which runs this constructor. So when you run this line of code, it is creating all of this. It is creating a new node with a value of 4. We're setting head and tail equal to that new node, and we're setting the length to 1. So now let's flip over to our code editor and take a look at this. So here is all of the code that we just wrote right here. So notice that our node class is inside of our linked list class. This is called an inner class. Since nodes are only going to be used in the linked list class, I did it this way instead of putting the node class in its own file. So in addition to these methods, I'm going to paste in a few more methods. So I'm going to scroll this up and paste those methods right here. So the methods are called printList, and this is just going to print out our linked list. It's just going to loop through it. I'm not going to walk through the code. And then we have getHead, getTail, and getLength. And with these, I'm having it just print out head and then the head value, and same thing with tail and length. And I just have these 4 in here so we can get visibility into our code, and it just makes it easier to troubleshoot things. So now I'm going to come over and zoom in here, and you can see we have a linked list package. That is the all lowercase linked list, and the linked list class is the file that holds all of our code that we're looking at here. And then I also have a class here called main, and I'm going to double click on this, and the main class is going to hold our main method. And we've already seen this line here. This is where we create a new linked list called myLinkedList, and we create it with a new node with a value of 4. And then here I'm going to run getHead, getTail, and getLength. And then with this line, we're going to print that list out. It's just going to have the 1 item in it. So before I run this, I'm going to close this side window. And now I'll run this. And you can see here that this has head pointing to a node with the value of 4. Same thing with tail. The length is equal to 1. And then our print list is only printing out the 1 item with a value of 4. So that means that we have a working constructor. So now that we're done building our constructor, let's write a method for adding an item to the end of the linked list. We'll call this method Append. So in the Append method, we're going to create a new node. Then we'll have the last node of the linked list point to the new node. We'll have tail point to the new node, and that will add that into the linked list. That's what it's going to look like if we have items in the linked list. But if we have an empty linked list, then we'll have head and tail point to that new node. So we'll start our append method out like this. We'll pass it a value. We'll use that value in creating a new node like this. So then the first situation we'll code for is when we have an empty linked list. This is where we have head and tail point to the new node. So in order to do this, we need to test to see, is the linked list empty? So we'll do that by saying if the length is equal to 0. You could also say if head is equal to null. You just have to have some way of testing to see, is the linked list empty? So if this is the case, we want to set head to be equal to new node like this. And then we also want to point tail to the new node like this. So let's put this in with the rest of our code. This is for if we have an empty linked list. And now we'll code for when there are items in the linked list by saying else. And now let's code out this else statement. So we'll say tail.next equals newNode. That is tail.next equals newNode. And then we'll say tail equals newNode, and that moves that over and adds the node into our linked list. So now let's add this code in with the rest of our code. And so far we have created a node, and this is if we have an empty linked list, and this is if we have items in the linked list. And the only thing left to do is to increment the length by 1. So we'll look at this code in a moment in our code editor, IntelliJ. And when we do, we'll create a linked list that looks like this. And then we'll run the append method on a new node with a value of 2, and we'll have a linked list that looks like this. So let's flip over to IntelliJ and take a look at this. So there is the append method that we just created. This is a method that has been added to the linked list class. And then we'll come up here to this tab. This is where we have our main class that contains our main method. And with this line here, we're creating a new linked list with a node with the value of 1. And then with this line, we're running the append method to add that second node with a value of 2. And then with this line here, we'll print that out. And I'll run this. And you can see up here, we have a new linked list that has the values 1 and 2, which means we have a working method for append. So now that we've written a method for adding an item to the end of the linked list, let's write a method for removing that item from the end of the linked list. We'll call this method removeLast. So before we get into this method, if you like this approach for learning about data structures, I want to tell you about my course that I have on Udemy. I use this approach throughout the entire course. At this time, it is 7.5 hours of content. In addition to covering linked lists, I also cover all of these data structures. We also go into detail with big O notation. There are 5 different sorting algorithms that are covered. We'll also talk about recursion, tree traversal, and other topics. So like I said, it's 7.5 hours of content. You can find that course at scottbarrett.com/Java. But by using this link, you can get the course at a significant discount. So now let's go back and talk about our removeLast method. So I'm going to break this into 2 parts. I'm going to do an introduction to talk about what we have to do to remove the last item, because it's much more complicated to remove the last item than it is to add an item onto the end of the linked list. And then after the introduction, we'll actually do a section where we walk through the code. So I'm going to bring up a linked list like this. And there are 3 different situations we have to code for. When we have 2 or more items and removing the item and returning it. Then we also have to code for when we have an empty linked list. And then there is also an edge case for when we have 1 item. So let's start by looking at when we have 2 or more items. So at first glance, this looks simple. You remove the node, you move tail back, you return the node, but it is much more complicated than that. So I'm going to bring this node back. So I had said previously that a node is very similar in structure to a hash map. So I'm going to turn this linked list into a set of nested hash maps. And like I said, it looks simple. We move tail up here. We'll say tail.next equals null, and then we can return this node. So I'm going to put this back the way it was, and we'll walk through this in a little bit more detail. In order to have tail point to this node, we need to set tail equal to another pointer that is pointing at this node. And on this screen, there's only one pointer that is pointing at this node. That is next from this node. So then we have to find a way to get to this node. And the only thing pointing at this node is the next value in this node, and so on until we get to the head. So we have to start at the head, which is pointing at this node, and traverse through the linked list until we get to this node. And it is only then that we can set tail to be equal to this node. Now that we've done that, we can say tail.next equals null, and then return this node. So let's take this and put it back to this type of diagram here, and we'll walk through this. We're going to start out by creating a couple of variables that I'm going to call pre and temp, and we're not going to need head and tail in the diagram for this. I'm going to move pre down underneath. And we're going to set up a while loop that says while temp.next is not null. And you can see that the linked list is going to be null at the end of the linked list. If it's pointing to another node, then that pointer is not equal to null. And when that happens, we'll have pre be equal to temp, and temp is going to be equal to temp.next. And then we'll continue running the while loop, and we'll check to see if this is null. And if it's not null, we'll move pre up and temp over. And this will just keep running like this until we get to the end. So this will be the last time that we move these. And now temp.next is equal to null. It breaks us out of our loop, and we end up with pre and temp just like this. So that temp variable will be what we return at the end of this, because we need to return that node that we removed. But for now, I'm going to take temp out of the diagram. So now that pre is pointing to the next to last item, we can say that tail equals pre, and that moves tail back. And that was the only thing we were using pre for, so I'll go ahead and drop that out. And then we can say tail.next equals null. That breaks that node off of the linked list. And I'll bring temp back here because at the end we'll say return temp. Okay, so that is our introduction to the remove last method, where we walk through the logic of this. Now we're going to write the code. So we'll start our method out like this. We'll call it remove last, and the return type is node. So the first thing we'll do is check to see, is the linked list empty? And we'll do that by saying if the length is equal to 0. You could also say if head is equal to null, and then we'll return null. So now let's write the code for when we have 2 or more nodes. And I'll bring in our variables, temp and pre, and let's go ahead and create these. We'll say node temp equals head. That points it at that node, and we'll do the same thing with pre. So now we can build our while loop. So we'll say while temp.next is not equal to null, we'll set pre to be equal to temp, which it already is in the first iteration. And then we'll say that temp is equal to temp.next. So let's move this down here, and then we'll walk through this while loop all the way to the end of the linked list. So while temp.next is not equal to null, it is not equal to null because it is pointing to a node. We set pre equal to temp. It's already equal to temp in the first iteration, and then temp equals temp.next, and that moves that over. So then we'll do this again, set pre equal to temp, temp equal to temp.next, and then we'll walk through this a couple more times. Pre equals temp, temp equals temp.next. And this will be the last time that we run this while loop. We move pre up, we move temp over, and this time temp.next is equal to null, and that breaks us out of this while loop. So we will be using that temp variable in a moment, but for right now, I'm going to remove it from the diagram, and we'll say that tail equals pre. That does this. And that was the only thing we were using pre for, so I'll go ahead and drop that out of the diagram. and we'll say tail.next equals null. That is tail.next equals null. And that breaks that node off the end of the linked list. So I'm going to take this code and bring it down here, and I'll bring these two variables back. And then I'm also going to bring back the rest of our code. So at this point, we'll decrement the length by 1, and that brings us to our other edge case that we talked about in the introduction, where we have one item in the linked list. So in this situation, head and tail are both going to point to this node, but also temp and pre, because they're equal to head, they are both pointing at this node. So I'm going to take temp and pre and all the code above it, and I'm going to remove it here, and then we'll walk through the rest of the code, and you'll see why this is an edge case. So first we'll say while temp.next is not equal to null. So that is temp.next. Well, that's already equal to null, which means we're never going to run this while loop. So I'll remove that. And we're not going to use the temp variable again, so I'm going to go ahead and drop that out of the diagram. And then we'll say tail equals pre. Well, tail and pre are both pointing at the same node, which means tail is already equal to pre. So we can remove that. Then we'll say tail.next equals null. That is tail.next. And that's already equal to null, so that's not doing anything. And the only thing left is to decrement the length. So the length was 1, and we decrement it, and it becomes 0. So we've run through all of this code. We've decremented the length, made that 0, but head and tail are still pointing to that same node. And that is the problem, and that's why this is an edge case. So what we're going to do is say if the length is equal to 0, and I'm going to bring our code back here because we have if length equals 0 here, and we have if length is 0 here. The difference for this second if statement is it happens after we have decremented the length. We started with a linked list with one item in it, we decremented it, and only then did the length become 0. So inside of this if statement, we'll just set head and tail to both be equal to null, which does this, and that solves the problem. The only thing left to do is to say return temp, which returns the pointer to the node that we removed. So we'll look at this code in a moment in IntelliJ, and when we do, we'll create this linked list with 2 items in it. And we're going to run the remove last method 3 times. We need to make sure it works when we have 2 or more items, and it works when we have 1 item, and then it also works when we don't have any items in the linked list. So now let's flip over to IntelliJ and take a look at this. So there is our remove last method that we just created. This is a method that has been added to our linked list class. Then I'm going to come up here to our main class that contains our main method. And with this line here, we'll create a new linked list with a node with a value of 1. And then we're going to append another node with a value of 2. And then with this line here, we will print this out. And I'll run this. And you can see up here that we have a linked list with nodes with the value of 1 and the value of 2. So what I'm going to do now is I'm going to come up here and I'm going to remove this line that says print list. I'm going to replace it with this. And with this code, we're going to run the remove last method 3 times. We're going to run it for when we have 2 items and 1 item and 0 items in our linked list. And now I will run this. And you can see up here, this has returned 2 nodes, and then it finally returned null. But I want to make sure that this is returning the correct nodes. So what I'll do is I'll come over here and I'll put .value here, and I will put .value here. Now, it is very important that you not do .value down here because this is returning null. It's not returning a node. So you can't put .value on null. Value is an attribute of a node. So now I'll run this again. And you can see that this returns the node with the value of 2, then the one with the value of 1, and then finally returns null. And it looks like we have a working method for remove last. And remove last is one of 3 methods that we have created here for the LinkedList class. If you would also like to learn how to create these other 7 methods for the LinkedList class, these are all in my course on Udemy. And once again, you can get to that course by going to scottbarrett.com/Java. And as I mentioned before, I always keep a coupon code attached to this link. I have to renew it every 30 days, but you can just go to this link and you'll get the latest coupon code to be able to get the course at a significant discount. So I hope you enjoyed the video. Please like and subscribe. And then I also have this link in the description below.